Hello students, we are discussing part test 6 physics solutions. Let's just get started. He's asking about which axis moment of inertia is going to be maximum. Axis is perpendicular to the plane of the disk. So we know moment of inertia passing through A is, I think this is a disk, so mr square by 2. About any other parallel axis, you need to use parallel axis theorem. So ID will be IG, I think here it is given as A, plus MD square. D is maximum for B, so it is B which is in option A. Option A will be your answer. Now in the second question, there's a cube, a horizontal force being applied at 1.2 meters. This cube needs to rotate about this lower edge. So the only forces which are applying torque are F and mg. So when torque greater than F is greater than or equal to torque greater than mg, it will start to turn. So we will find minimum force by equating them. So F into 1.2 must be equals to mg into A by 2. A by 2 will be this perpendicular distance. Substituting the values, we will get 1.96 into 10 power 4, which will be option C. We have Earth. Earth is a solid sphere. We need angular momentum. Time period is 2 pi by t. So angular momentum is I omega. Solid sphere moment of inertia is 2 by 5 mr square. Omega. Time period is given, which will be 2 pi by t. So it will be 4 pi mr square by 5t. 4 pi mr square by 5t. Yeah, here power is given 100 kilowatt. Omega is given in 8 revolutions per minute, 1800. Revolution is 2 pi radians. 1 minute is 60 seconds. 0, 0. This will be 30. So omega will be 60 pi. Now they are asking torque. So power is I omega. As you know, power is force into velocity in linear terms. In angular terms, it will be tau into omega. So tau, we need to find torque. So torque is going to be power by omega. 100 kilowatt, 100 into 10 cube, omega is 60 pi. Simplifying, it will be 531. Tau is 0. Tau is nothing but I alpha. So alpha equal to 0. Now in the next question, he's asking work done should be minimum. So work done, if they are purely rotating, work done is change in kinetic energy, which will be half I omega square. So moment of inertia has to be minimal for the work done to be minimal. Now moment of inertia will be given by m1 x square. For a point mass, it will be m1 r square plus m2 into L minus x whole square. This is a function of x. If you differentiate with respect to x, this will be 2m1x plus 2m2 L minus x into minus 1, 2L minus 1. We'll equate this to 0. On equating this to 0, you will get m1x equal to m2 into L minus x. So x value will be m2L by m1 plus m2, which is also center of mass of the system. So when axis passes through center of mass, moment of inertia is minimal, which gives us option C. Yeah, in this question, diameter of A, diameter of C, these both is same. So from equation of continuity, A1 V1 equals to A2 V2, area is same, their velocities are going to be same. So the rise in this container and this is going to be same, which will give us option D. Now force is given, force as a function of time, we need to calculate distance. So acceleration is F0 by m cos pi by 2t. So to find velocity, we will integrate once, F0 by m. Integration of this will be sine pi by 2t by pi by 2. So by pi by 2, I am writing here it as 2 by pi. Now what will be the limits 0 to t, and limits of velocity will be 0 to v. Initial velocity is 0. When you substitute 0, sine function will give you 0. So this function will simply be this, v equal to 2f naught by m sine pi by 2t. He's asking when will the velocity become 0 for the first time. The particle stops, that is velocity 0. So if you look at sine graph at t equal to 0, and when angle is pi it will become 0. You want this to be pi, so t value will be 2. Integrate again, you will get x value 2f naught by pi m into integration of sine will be minus cos pi by 2t. Limits will be from 0 to t. You can switch the limits with this minus sign. When you substitute 0, the value will be 1. So x function will be 2f naught by pi m into 1 minus cos pi by 2t. When you substitute t equal to 0, cos pi will be minus 1. 1 minus minus 1 is 2. 2 into 2, and integration constant by pi by 2. So this will be 2 into 2 into 2, 8 f naught by pi square m, which will give us option C. So we have a container. We need time taken for the level to drop from h1 to h2. So velocity of efflux is under root 2gh when this height is h. So basically to find this, we will equate volume going out here is volume that is dropping here. What is the, let's say this is 1 and this is 2. So which gives us a1 v1 will be a2 v2. What is the velocity of efflux? Velocity of efflux will be under root 2gh. And a1, what is v1? v1 is the velocity with which this water level is coming down, which will be dh by dt. Now in question it is given that this larger area is capital A and the small, right? Yeah, smaller area is small a, larger area is capital B. Now capital A by small a, dh by under root h is root 2g into dt. Just a second, adding a slide. Right. Now here, what is this that we got? Capital A by small a, dh by under root h is equal to root 2g dt. Integrate on both sides, 0 to t, so time taken, and here integration of 1 by 2 root h will be root h, so multiplying 2 to 2a by a root h. Limits will be from h1 to h2, so it will be under root h2 minus under root h1, and when you take this under root 2g here, so it will be capital A by small a root 2 by g root h2 minus root h1, which will give us h1 to h2, so it will be root h1 minus h2, so which will give us option D. Before capital A, here we have g by 2, so it will be 2 by g, which will make it option A. Moving on to the next question. It is given cross-sectional area of A is half that of B. So A, cross-sectional area of A is cross-sectional area of B by 2. Now he said in question that stress is strain, same for both of them. So stress is TA by AA equals to TB by AB, which gives us TA by TB is AA, which is simply AB by 2, TA by TB will be 1 by 2. Now for them to produce equal stress, this is the condition, TA by TB equal to 1 by 2. Now writing torque equation about this point, about which weight is passing through. So net torque should be 0. So TA into x must be equal to TB into L minus x. So TA by TB is 1 by 2, which is L minus x by x. So x equal to 2L minus 2x, x equal to 2L by 3, which will give us option C. Now in this question it is given there are two soap bubbles of radius x merged to form soap bubble of radius y. This process is isothermal. Given atmospheric pressure is P. So to find surface tension, let's just assume that the inside pressure is P1 here and P2 here. So the excess pressure is 4T by R. So P1 minus P will be 4T by X. Similarly, P2 minus P will be 4T by 5. Here we have two variables P1 and P2. We need to eliminate them. So we need one more relation. We get one more relation, P1 V1 equal to P2 V2, because it is an isothermal process. P1 into what is the initial volume? Two bubbles are there. 2 into 4 by 3 pi R cube x cube. 4 by 3 pi, 4 by 3 pi will anyway get cancelled. So P2 into y cube. So what is P1 by P2? Will be y cube by 2x cube. Now this is, let's say, one relation. You have P1 is P plus 4T by x, P2 is P plus 4T by y. When you divide with these both and find T, LHS will be y cube by 2x square, 2x cube. And simplifying for T, we are going to get option C. Moving on. Yeah, the basic fact is if acceleration due to gravity is g, pressure at a height h is rho g h. Now suppose if there is no gravity and it is accelerating with a, at this height the pressure will be rho OHA. Now both of them are happening, so the pressure will be rho GH plus rho AH, so rho H into G plus A. Okay, one of them is L, so instead of this H we have L. Anyway, it will be option C. Moving on to the next question. So we have a film soap solution and a thread is placed which will become circular. So we will take a very small part on that circle. So tension will be along the string, along this circle. Now let's say this angle is theta. So dropping here, this angle will be half angle. This will also be theta by 2. So taking components, this will be t cos theta by 2, t cos theta by 2, which will get cancelled, which will leave us in the vertical with 2t sin theta by 2. And since two layers are there, the force on this is, okay, let's say surface tension is T, so let's say tension is F. This is F. So 2t, force will be given by into length, 2 times surface tension into, let's say length is delta L which is nothing but r theta. Now these two forces must cancel each other out. 2t into r theta must be equal to 2f sine theta by 2. If angle is very small, sine theta by 2 can be approximated as theta by 2. So 2 theta cancel, which will give us f is 2tr. Option D. Two drops of same radius merge together. If two drops merge together, we can equate their volume to find their final radius. So initially, let's say 2r cube, volume is proportional to radius, 4 by 3 pi will get cancelled, r dash cube. So r dash is 2 power 1 by 3 into r. Now terminal velocity is proportional to small r square. So initial terminal velocity by final will be initial radius by final radius whole squared. When you square, it will be 2 power 2 by 3 into r square cancelled. V final will be 2 power 2 by 3 into V initial, which is 5. 2 power 2 by 3 can be written as 4 power 1 by 3 into 5 centimeters, which will be option C. Particle is executing SHM, kinetic energy when displacement is half the amplitude. So we are going to use, we need kinetic energy. Kinetic energy is total energy minus potential energy. Total energy is half m omega square a squared. Yes, minus potential energy is half k x squared. K is m omega square. So half m omega square a square minus x square, given x value is a by 2, so it will be a square by 2. So this will be 3 by 4. 1 minus 1 by 4 will be 3 by 4, half m omega square a square, which is total energy, so it will be 3 by 4 E. Option B. Now in this question, some springs are in series and some springs are in parallel. In parallel, K effective will be K1 plus K2. So here K effective is 2K, here K effective will be K by 2, here K effective will be K. In series, you will find 1 by K effective is 1 by K1 plus 1 by K2. So K effective will be K by 2. Now we need ratio of time periods. So it will be 2 pi root m by K time period. Mass is same in all the cases. So it will be ratio of 1 by K. So 1 by root K is to 1 by 2 by K is to 1 by root 2K. K cancelled. 1 is to root 2 is to 1 by root 2, which will be option D. Moving on to the next question. It's given time period is T. So time period is 2 pi root L by G. T square is 4 pi square L by G. So T square is some constant into length. Now what is T1 when length is increased by 10? So it will be the same constant into L plus 10. What is T2? Same constant into L minus 10. Now we need relation between these two. So when you add these both, you will get T2 square plus T1 squared is 2KL, which is KL by 2. Which is nothing but 2T square. 2KL is nothing but 2T square, so 2T square is T1 square, which will give us option C. Yeah, 43 is a theoretical question. For example, you have air drag or so the relation will be given by minus some constant into V. Force is proportional to velocity, and this minus sign here stands for opposite direction. So acts opposite direction proportional to velocity, which will give us option D. Right, we have one rod We have one rod, the rod is hinged at the center. Now a small mass m is moving with angle pi by 4. So mass is moving with angle pi by 4, that is 45 degrees with initial velocity v. So if you take components, it will be v by root 2 and v by root 2. So when it is hitting, only velocity in horizontal will change, vertical will remain the same. So we solve this problem by conservation of angular momentum. Angular momentum initially equal to angular momentum final. Now this only in x direction, we are conserving angular momentum of this horizontal velocity. So initial angular momentum will be m v by root 2 into this distance, which will be L by 2, and final angular momentum, both of them will stick together and move with the same angular velocity omega. So moment of inertia will be, the mass of the rod is 4m L square by 12 plus small m into L by 2 whole square. This small m is stuck here. Now on simplifying, you will get omega as 3 root 2v by 7l, which is not there. I hope you have made the correction in option B, 3 root 2v by 7l. So option B. Irrespective of how you place this mass system, be it horizontal or vertical, the time period will be 2 pi root m by k. Here k effective will be 2k because springs are in parallel, m by 2k, which will give us option A. Moving on to the next question. So both upper layer and these two spheres are rolling without slipping. So let's look at the top sphere. Here velocity is 2v, here velocity is v, that is v towards left. If it is rolling, velocity at the top point is v center of mass plus r omega, which is 2v. At the bottom point, it is v center of mass minus r omega. So the velocity is towards left, we are taking minus, so this v is towards left minus v. Now we need omega, so subtract these two relations. 2r omega will be 3v. We'll get omega from here. Now writing the same equation for lower sphere, here velocity is towards left. This point of contact velocity is 0. So it is spinning this way. So at the topmost point, v center of mass plus r omega is v. V center of mass minus r omega is 0. Subtracting both, 2r omega is v. This is omega lower, this is omega upper. When you take ratio, RH, 2r cancel in LHS, 3v by v will be 3. So answer will be 3. Now when both of them are brought into contact, frictional force is applied. On both the discs in equal and opposite directions. So this is rotating this way, friction will try to slow it down. Here friction will try to speed it up. Here what we can do is, velocity of final angular velocity is such that velocity of point of contact is same. Let's say here velocity is omega 1, here velocity is omega 2. This is the bigger sphere and this is the smaller sphere. So what is the velocity at this point? Omega 1a. What is velocity at this point? Omega 2a, b. So this is the first relation we have in omega 1 and omega 2. That is omega left. Omega left is omega 1. Now we can conserve angular momentum by taking friction as an internal force, but for that we need moment of inertia of B about axis passing through A. Instead of that, we can write angular impulse is change in angular momentum. So what will be angular impulse on A? Frictional force is acting and the torque produced will be F into A. Torque into delta T will give us angular impulse, which is change in angular momentum I1. Initially it was omega naught, finally omega. The same angular impulse on B will be friction. Same friction force will act into delta T will be I2 into omega 2. Adding a slide. Now when you divide these both, you will get A by B. A by B is equal to omega naught minus omega 1 into I1 by I2 into omega 2. Now we need omega 1. So omega 2 is omega 1 A by B. Substitute omega 2 here. Omega 1 into A by B. So this will be I2 omega 1 A square by B square equal to I1 omega naught minus omega 1. We need omega 1, which will be I1 omega naught. Send this here, take omega 1 common. I1 plus I2 A square by B square. He asked, this is X, this is Y. So 2 plus 2 is 4. So answer is going to be 4. Now diagram is little misleading, but this mass is entirely immersed. So tension acting upwards, buoyant force also acting upwards, and capital Mg, which is 100 Newton, acting downwards. So tension plus buoyant force is 100 Newton. And what is, now draw free body diagram for small m. Tension will be small mg. Tension is small mg plus buoyant force equals to 100 Newton. So we need to find buoyant force. What is buoyant force? Density of water into volume of this capital M into G. We have specific gravity of the material. So when you divide by raw material, this raw material into Vg is 100. Raw material by raw water will be 2.5. So bringing this rho W down, it will be by 2.5, which will be 40. So buoyant force is 40. Small mg is 100 minus 40, 60. Small m is 6 kg. So answer will be 6. Now you have capital M and small m. What is the maximum force that you can apply? So on small m, only friction is acting. Small m is 1 kg. So normal reaction is 10 Newton. F max is mu, 0.4 into 10, 4 Newton. So F max is 4. A max, maximum acceleration of 1 kg will be 4 by 1, which is going to be 4 meter per second square. So the maximum acceleration that you can give to this small m is 4 meter per second square. And the maximum acceleration is when it is in extreme position. In extreme position, this will be, now if you want both of them to move together, it is kind of like a block of 10 kg. Force is kx and ka, amplitude is going to be a in extreme position. So ka should be 10, maximum acceleration is 4. Now k is given as 200, so this will be 40 by 200, 1 by 2 by 10, 0.2 meters or 20 centimeters. So answer will be 20. Right, now see, the point of the question is time period is given so that we get the value of k. So k is m omega square, omega is 2 pi by t, 4 pi square by t square. Now substituting m 4.9, this is 4, g value they said 10, 1 by 2 whole square will be into 4, by 1 by 4, 4 is going to go up. See now, when you hang this and this is oscillating, at mean position kx equals to mg, and when you remove the block it will go back to its natural length, so it will compress by this x, so x is mg by k. M is given as 4.9, G is 10, K is 4.9 into 4 into 10 into 4. On simplifying, we get the value as 6.25 centimeter, can be approximated to 6.